Okay, last part of this video series is solving for matrices. So figuring out, like, if I took this matrix 1, 2, 2, 3, what matrix would I have to multiply it by to get this matrix 4, -1, 5, and 2. Alright, so it's just like a linear equation, you do inverse operations. The biggest difference is that you can't divide matrices, you have to multiply by the inverse. And you have to pay attention to the order. So if you multiply a matrix on the left-hand side of one equation, you must multiply it on the left-hand side of another equation. So let's see how we can figure out what matrix X is. So first thing I'm going to do is rename this matrix A, okay? Keep that as matrix X, and then call this matrix B, so that I could just write this out more easily. So I want to get X alone. I can't divide by matrix A. There's no such thing as matrix division. So what I'm going to do instead is take the inverse of matrix A and multiply it on the left-hand side on both sides of the equation, on the left-hand side. So let's find the inverse of matrix A first. Okay, that's going to be 1 over the determinant. So 1 times 3 is 3, minus 2 times 2 is 4. So that's going to be 1 over -1. Times, okay, we're going to switch A and D, so put a 3 there and a 1 there, alright, and then negate B and C. So that's the definition of an inverse, right? And you can do this on the calculator as well, and I'll show you how. So now we get -1 over just -1 times 3, 1, -2, -2. So when we distribute that -1, we get -3, 2, 2, and -1. Okay, so that right there represents the inverse of matrix A. Okay, now we are going to take that inverse of matrix A and multiply it on the left-hand side, on both sides of the equation. So I'm going to write that out right now. Okay, so now I kind of color coordinated it with the above equation, showing that I'm putting the inverse on the left-hand side of both sides of this equation. Now, this here, I should know that it's going to come out to 1, 0, 0, 1, the identity matrix, because this matrix is the inverse of this matrix. Alright, now if we just check that, if we do -3 times 1 is -3, 2 times 2 is 4, add that together and you get 1. Alright, -3 times 2 is -6, plus 2 times 3 is 6, that's just 0. Okay, and then take second row times the first column, so 2 times -1, or sorry, 2 times +1 is 2, plus -2 is 0, okay, and then 2 times 2 is 4, -1 times 3, that adds up to 1, okay, so whatever matrix X is, it's going to multiply to this matrix to just equal X, because the identity matrix times anything is itself. So now to see what X equals, I have to multiply these two matrices over here. So I'm going to take row 1 times column 1, and it comes out to be -12 plus 10, so that's a -2. Okay. Then I'm going to take row 1 times column 2, and that's going to give me 3 plus 4 is 7. Then I'm going to take row 2 times column 1, okay, so that gives me an 8 plus -5, that's a 3. Then I'm going to do row 2 times column 2, so I get 2 times -1 is -2, plus -2, and I get -4. Alright, so this is the matrix that I should multiply by that matrix to give me this one, and I could check that on a calculator. Okay, so you can see over here that I took this matrix and then plugged in what I got for matrix X, multiply it together, and I got what it should equal. So you could check these with a calculator too. And in the last example, I'll show you how you could just do this whole thing on a calculator without using the solve function.